moderate velocity, right? So your strength of vector should be moderately. It's not you can make like this also, right? So first of all, the first wave, which is due to the atrial depolarization, the positive charge is going towards the positive electrode. The first wave is the P wave of moderate velocity. Clear? Now don't write, I'm drawing everything, just understand. The next is the second event, AV nodal depolarization. I told that AV nodal depolarization is a very small vector and it will not be picked by the galvanometer, right? So you will not get any wave. Instead, what you will get is a straight line, right? The next vector is the septal depolarization. The positive charge is going away from the positive electrode. So negative. So the galvanometer now will go down. And it was a good velocity. So it will not be a, it will just very quick wave. Right? So here it is going away from the positive electrode. The next vector is major ventricular depolarization. It is a big vector. Positive vector going towards positive electrode, giving a positive deflection. Next, what will be the direction of vector will be? The wave will be negative because it is the positive charge is going away from the positive electrode. So this is again a negative. Right? Now what is happening is at this point of time, now whole of the heart is depolarized, and always remember the principle. When the heart is fully depolarized or fully repolarized, will there be any vector?
No.
So next will be isoelectric line. Clear? So this is P wave, this is Q, R, S, now till S, and this is the isoelectric line. So this is all depolarization. In this, when the atria was depolarizing, simultaneously the ventricle is also depolarizing, but at this point the atria was repolarizing. But since this is a major ventricular depolarization, so atrial repolarization will be masked by the ventricular depolarization. So we will not see any atrial repolarization. Till this clear? So at this point, I should have drawn here, this is the position of heart. Everything is depolarized. That's why it's a straight line. Isoelectric line. Now you can write it. So till now we have just seen the events of depolarization, ventricular depolarization and atrial repolarization, which is masked by the ventricular depolarization. Right? So I'm going to rub this vectors because this was depolarization is now over. Now the heart is going to recover. Now for repolarization, if you remember, what are the ions which are now what will happen for repolarization? Which channels are important?
Potassium.
Potassium. So now what will happen? There will be negativity inside, right? So when we saw the depolarization, again we will revise one thing, that when the depolarization happened, it started from the septum, right? And then next cell, and then next cell, then next cell, then next cell, like this, because the Purkinje fibers are here. It is why the depolarization from inside to outside. Isn't it? Now, when the heart is going to recover, now what is going to happen? Now, if you see the inner myocardium, this is called subendocardial myocardium. It's called subendocardial myocardium. It is actually, pumping very fastly. But if you see, this is actually called subpericardial myocardium. Or if you don't want to remember this thing, just remember when the heart is contracting, it is in a systole stage, the inner part is getting less blood or this is getting less blood. You see the capillaries. Okay, so this is getting squeezed. They're getting squeezed when this heart is contracting. Which area is more compromised, inner or outer? Inner. So this area will be having comparatively more blood than innermost heart, isn't it? Since it is having more blood, this is the area which is going to recover very fast. So that is why repolarization starts from out to in. Number one, right? So repolarization is from out to inwards. The second point is the repolarization. In the repolarization, if we see, we only get one vector, right? We will get only one vector, one negative vector, and since it is going from out to in, the vector will be pointing like this. Why we will get one vector? Number one, because it is due to potassium channels, and potassium is much slower than sodium, right? So instead of getting so many vectors as we were getting in repolarization we will get one vector which is smaller than the depolarization vector. Number one, because this is got the potassium channels, the small vector is there and single vector is there. Small and single vector, and the direction will be upwards and outwards. So if we see, this is a negative depolar, this is negative vector going towards negative
Positive.
but with a moderate velocity. It's not a very slow vector, right? It's a moderate velocity. So the T wave when it comes, it is actually a bigger than a P wave, because the P wave was because of the atria and this is because of the ventricles. So definitely it's the bigger wave. But this is the most common mistake students make, is they make P wave and T wave look similar. Now you understand they cannot be similar, because the origin is from atria, here the origin is for ventricles. How can they be same? Right? So the T wave is a upstroke wave. Clear now? Why negative vector going towards negative electrode? It's recording a positive deflection. Clear? So this is about the depolarization and repolarization. Right? So now next we are going to focus on the waves and the segments and the intervals. So everybody has written this part. I want everybody to write it and try to remember it also. I will make sure that you remember in the class only. Everybody, anybody wants any kind of revision here? Should we move forward? So coming back to the ECG waves and the segments, I'm going to make a big ECG and we are going to see how we are going to remember them also. See, most of the time students find it difficult to remember the durations, and these are the most common questions put in the Viva also and theory also, right? So the first is I'm going to draw them. Let us see what is the difference between a wave and a segment. ECG pattern which we get, right? So waves, then segments, and then intervals, right? So how many waves we have? P, Q, R, S, T. So we have P, Q, R, S, T. What do we define waves? Waves are the deflections in the galvanometer, right? They are the deflections which are called as waves. What is the meaning of a segment? Segments are the isoelectric parts in the ECG. So what is the isoelectric we have? PR segment. Actually it should be called PQ segment, but in most of the ECGs Q is sometimes not visible also. So we say it is a PR segment and ST segment. Right? Then we have, what is the meaning of an interval? Now interval can be number of waves together. More than one wave is also interval, like QRS interval. There are 3 waves, right? So we have intervals like QRS interval, or the interval can be wave plus segment. It can be PR interval.